Okay, so the next question asks, when oxygen and sulfur atoms become monatomic ions, how many electrons does each lose or gain? Which noble gas atom has the same number of electrons as an oxide ion? And which noble gas atom has the same number of electrons as a sulfide ion? Okay, so to answer this question, we would need to know the electron configurations of both oxygen and sulfur, just when they are in their ground state configurations. So for oxygen, let's try to find out its electron configuration. Okay, so oxygen is found here, atomic number 8. And now that we've found it, you'll notice that the periodic table is divided into different sections. So each of that corresponds to a different block number. So the light blue section is the s orbital. This green section is the p orbital. And then this orange section is the d orbital, which is the transition metals. And then the bottom two rows is the f orbital. So these are all the lactanides and actinides. So when you write down the electron configuration, you want to start from hydrogen and then move from left to right, top to bottom, until you get to your desired element. So you want to write down the row number first, and then the block number, and then show how many electrons are in each orbital for that atom. So starting at hydrogen, moving on to helium, we write 1s2. And then on to the next row, so 2s2. And then moving to the right, we write 2p, and then count up to the oxygen, 1, 2, 3, 4. 2p4. So when oxygen becomes an ion and it has a 2- charge, what this also means is that it gained 2 electrons. So because it gained 2 electrons, its electron configuration will also change, and we are going to add 2 electrons to the 2p orbital that we ended at. So now our new electron configuration is 1s2, 2s2, and then 2p6. And then if we look at our periodic table, we'll see that it now has the same electron configuration as neon. So I'm just going to write over here, square brackets, Ne. Okay, so that's for oxygen. So let's try to do the same thing for sulfur. So the electron configuration of just a neutral ground state sulfur atom would just be 1s2, 2s2, and then 2p6, and then moving on to the third row, we have 3s2, and then 3p, and we also count 4. Okay, so it's similar to oxygen, except it is just a row under it. So now, again, we'll write what the electron configuration of sulfur would look like if it were to gain 2 electrons. Its new electron configuration would be 1s2, 2s2, 2p6, 3s2, and then 3p6. Again, if we look at our periodic table, it now has the same electron configuration as argon. So I'm just going to put argon in square brackets. Okay, so let's see what the junior tutor said. You can use the periodic table to predict whether an atom will form an anion or a cation, and also predict the charge of the resulting ion. Electrons lost or gained. So oxygen has an electron configuration of 1s2, 2s2, 2p4. Sulfur has an electron configuration of 1s2, 2p6, 2s2, 2p6, 3s2, 3p4. Both oxygen and sulfur are in group 6 with p4 orbitals. As a result, both elements require 2 electrons to obtain a noble gas configuration. Noble gas with the same number of electrons, so they just showed that oxygen with a -2 charge forms an electron configuration similar to neon when it gains 2 electrons, and the sulfur ion forms an electron configuration similar to argon when it gains 2 electrons. Yep, so this solution is correct.